Good morning, students. Today we'll start a new chapter of Geography, Chapter 3 Water Resources. So let's start with the chapter Water Resources. As we already know that 3/4 of the Earth's surface is covered with water, but only a small proportion of it accounts for fresh water that can be put to use. This fresh water is mainly obtained from the surface runoff and groundwater that is continually being renewed and recharged through the hydrological cycle. All water moves within the hydrological cycle, ensuring that water is a renewable resource. You might wonder that if 3/4 of the world is covered with water and water is a renewable resource, then how is it that countries and regions around the globe suffer from water scarcity? Why is it predicted that by 2025 nearly 2 billion people will live in absolute water scarcity? Water scarcity and the need for water conservation and management. The abundance and renewability of water, it is difficult to imagine that we may suffer from water scarcity. The moment we speak of water shortage, we immediately associate it with the regions having low rainfall or those that are drought prone areas. We instantly visualize the deserts of Rajasthan, women balancing many mud cars used for collecting and storing water and traveling long distance to get water. True, the availability of water resource varies over space and time, mainly due to variation in seasonal and annual precipitation. But water scarcity in most cases is caused by overexploitation, excessive use, and unaccess to water among different social groups. Where is then water scarcity likely to occur? As you have read in the hydrological cycle, fresh water can be obtained directly from precipitation, surface runoff, and groundwater. Is it possible that an area or region may have ample water resource that is still facing water scarcity? Many of our cities are such examples. Thus, water scarcity may be an outcome of a large and growing population and consequent greater demands for water and unequal access to it. A large population means more water, not only for domestic use but also to produce more food. Hence, to facilitate higher food grain production, water resources are being over exploited to expand irrigated areas and dry season agriculture. You may have seen in many television advertisements that most farmers have their own wells and tube wells in their farms for irrigation to increase their produce. But have you ever wondered What this could result in? That it may lead to falling groundwater levels, adversely affecting water availability and food scarcity of the people. Now moving to the other part of the water resource. Post-independent India witnessed intense industrialization and urbanization. Today, large industrial houses are a commonplace as an industrial unit of many multinational corporations. The ever increasing number of industries has made matter worse by exerting pressure on existing freshwater resources. Industries, apart from being heavy users of water, also require power to run them. Much of this energy comes from hydroelectric power. Today in India, hydroelectric power contributes 22% of the total electricity produced. Moreover, multiplying urban centers with large and dense population and urban lifestyle have not only added to water and energy requirements but have further aggravated the problem. If you look into the housing societies or colonies in the cities, you would find that most of those have their own groundwater pumping devices to meet their water needs. Not surprisingly, we find that fragile water resources are being overexploited and have caused their depletion in several of these cities. So far, we have focused on the quantitative aspects of water scarcity. Now let us consider another situation where water is sufficiently available to meet the needs of the people, but the area still suffers with water scarcity. Lately, there has been a growing concern that even if an ample amount of water to meet the needs of the people, much of it is being polluted by domestic and industrial wastes, chemicals, pesticides and fertilizers used in agriculture. You may have already realized that need of the hour is to conserve and manage our water resources, safeguard ourselves from health hazard, ensure food security, continuation of our livelihood and productive activities, prevent degradation of our natural ecosystem. Overexploitation and mismanagement of water resources will impoverish this resource and cause ecological crises that may have profound impact on our lives. Now moving to rainwater harvesting. In the ancient India, along with the sophisticated hydraulic structure, there existed an extraordinary tradition of water harvesting system. People had in depth knowledge of rainfall regimes and soil types. People had in depth knowledge of rainfall regimes and soil types. They developed wide ranging techniques to harvest rainwater, groundwater, river water, and flood water in keeping with the local ecological conditions and their water needs. In hilly and mountainous regions, people built diversion channels like the gulls and kuls of the western Himalayas for agriculture. Rooftop rainwater harvesting was commonly practiced to store drinking water, particularly in Rajasthan. In the floodplains of Bengal, people developed inundation channels to irrigate their fields. In arid and semi-arid regions, agricultural fields were converted into rain-fed storage structures that allowed the water to stand and moisten the soil, like the khandis in Jaisalmer and Johats in other parts of Rajasthan. In the semi-arid and arid regions of Rajasthan, particularly in Bikaner, Bahlodi and Barmer, almost all the houses traditionally had underground tanks or tankees for storing drinking water. The tankees could be as large as a big room. One household in Bahlodi had a tank that was 6.1 meter deep, 4.27 meter long, and 2.44 meters wide. The tankees were part of well-developed rooftop rainwater harvesting system and were built inside the main house or the courtyard. They were connected to the sloping roofs of the houses through a pipe. Rain falling on the rooftops would travel down the pipe and was stored in these underground tankees. The first spell of rain was usually not collected, as this would clean the roof and the pipes. The rainwater from the subsequent showers was then collected. The rainwater can be stored in the tankees till the next rainfall, making it an extremely reliable source of drinking water when all other sources are dried up, particularly in summer. Rainwater, or balar pani, as commonly referred to in these parts, is considered the purest form of natural water. Many houses constructed underground rooms adjoining the tanka to beat the summer heat, as it would keep the room cool. Today, in the western Rajasthan, sadly, the practice of rooftop rainwater harvesting is one the decline, as the plenty of water is available due to perennial Rajasthan Canal. Though some houses still maintain the tankees, since they do not like the taste of the tap water. Fortunately, in many parts of rural and urban India, rooftop rainwater harvesting is being successfully adapted to store and conserve water. In Getuthar, a remote backward village in Mysore, Karnataka, village have installed in their households rooftop rainwater harvesting system to meet their water needs. Nearly 200 households have installed this system, and the village has earned the rare distinction of being rich in rainwater. With 80% of collective or collection efficiently and of about 10 fillings, every house can collect and use about 50,000 liters of water annually. From the 20 houses, the net amount of rainfall or rainwater harvested annually amounts to 1 lakh